One of the patches included in the examples directory of the Max package, MIAP package, which should be found in, if you've installed it correctly, packages MIAP for Max examples, is a patch that visualizes the speaker gains, allows you to take the abstracted topological space of a space map and translate it to real space through an OpenGL renderer. And this, let me just open up the patch first. This patch takes in JSON files that I've provided configuration files for every example map that is provided in the drop-down menu in the MIAP and MIAP help patches. So let's take a look at one of them. And the comments pretty much tell you everything you need. You can specify locations of speakers, either derived nodes or speaker nodes of a map in Cartesian or spherical space. This is a JSON file, so you have a speakers object, and inside there you indicate the channel number of the speaker, a speaker node or derived node, and then a list, an array, which in this case is azimuth, elevation, distance. If it was Cartesian, it would be x, y, and z, and there's some information about the orientation of the coordinate space here. And that's it. So we open up this patch. Let me load in a simple, let's load in 4-channel. And then you can move around to view it, zoom in and out. If you know a little bit of jitter programming in Max, you can do a lot more by just looking under the hood, reset the view. There's a little README that explains everything here and explains how it walks you through how to open up the MIAP help patch and load something in. And this receives messages from the help files to smap viz. You can change this with whatever. You can use open sound control over the network, whatever you want. But all the help patches, the Panner help patches are sending their gains, the interlaced list of channel number and speaker gain to this patch. And as an example, let me load up let's load up one of these quad patches here. And then I'll pan around so you can see. All right, so this object, the panner in this help patch, is sending those speaker gains to this visualizer patch. And it's giving you an indication in real space. This is a pretty concrete example. This isn't a really abstracted space. It's kind of a top-down view of a space, of a quad speaker setup. But if this was a very strange abstracted topological space, you could translate it back to real space and see how these speaker gains are actually manifesting in a virtual 3D space. And that is the MIAP Map Speaker Viz patch.